Hey, I'm Karthik, and today we're going to explore a serious game called The Cure. The Cure is a game where players build decision trees to predict breast cancer survival time. The underlying aim of this application is to combine all of this player data and develop a classifier that will more intelligently predict the survival time of breast cancer cases. The Cure is housed at this URL, genegames.org/cure. To begin playing, let's just hit play now. This takes us to a login page where we can either enter our login details, or if you're a new player, you can click on new player and fill up this short sign up form. For now, let's just use my login ID. This is the game page where we'll be building all our decision trees. As you can see, the aim is to build one that predicts 10-year survival using gene expression and clinical variables. You can add genes or clinical features by using this small control box here. You can toggle between clinical features and genes using this little toggle button. You can add genes either by the names or by the functions. Let's say apoptosis, and all the genes relevant to this particular function are shown in this drop down here. Let's try adding a gene by its gene name. Let's add ORCA. You can see here that ORCA is in the drop down, and this little pop-up box here shows a summary of the gene's function and its gene riffs. Let's select ORCA. As you can see, the tree built by choosing ORCA has 3 different nodes. This node is called the split node, and these 2 nodes are called the leaf nodes. Predictions are usually made in these leaf nodes. Choosing ORCA has 2 different predictions. One prediction is where cases with a low expression level of ORCA are predicted to survive beyond 10 years, which is a favorable outcome represented by the blue color. The other outcome is an unfavorable outcome, in this case where high expression levels of ORCA usually mean that cases are not predicted to survive beyond 10 years. You can see on the right here that the tree has been scored at 60,000. The chart below the tree shows the score transitions based on the nodes you've added. The height represents the score, and it has 3 different components: accuracy, size, and novelty. Hovering on each bar shows the individual components. The individual attributes of the tree can be seen here. The accuracy of this tree is 59%, the size is 3 based on the 3 different nodes that are here, and the novelty of the tree's predictions is 65%. To see a textual description of the predictions made by the tree, you can click on Show Tree Explanation. You can see here that cases with a low expression level of ORCA have a favorable outcome, and cases with high expression levels of ORCA an unfavorable outcome. To actually see the nodes that lead to this prediction, you can click on Show in Tree. You can see that these 3 highlighted nodes lead to a favorable outcome. Similarly, these 3 nodes lead to an unfavorable outcome. Let's add another node. This time let's add a clinical feature. We can switch to clinical features by hitting this toggle button here. You can choose from a list of 12 clinical features. For now, let's just choose ER expression. We can see that choosing ER expression has changed our score from 60 to 61,000. You can see how the score has transitioned based on the chart here, and the current attributes of the tree are shown here. These values represent how adding each node has affected your score. Now that we've built the tree, let's try saving it. You can save it by clicking on Save Tree here. You have an option to save the tree along with a comment. You also have an option to save the tree as private in case you don't want other users to see your tree, in which case it will not be included in the scoreboard. You can see that the tree has been ranked 67, and this window here shows the scoreboard. You can view any other tree in the scoreboard simply by clicking on it. To go to your profile page where you can see your tree collection or your badge collection, you click on My Profile. Since my screen is very small, I will hide this chart and we can navigate to My Profile. Clicking on My Profile opens up a new window where you can see your badge collection. As you can see, these are the badges that I've earned, and these are the badges I have yet to earn. I can try earning a badge simply by clicking on Get Badge. Now I get this badge simply by creating a tree with a score greater than 68,000 and with a size greater than 7. Let's try doing this. Let's start by adding a clinical feature, say lymph nodes positive. As you can see, my score is 68,000 but my size is still 3. Let's add a gene, say MRPL1, 2. You can see here my size is still 5. Let's try adding. You can see here that my size is 7 and my score is 68,000. Let's try saving this tree. You can see that I've earned new badges. You can view the badges that you've earned by clicking here. Great, so this badge is in my collection. I can go back to my profile by clicking on open my profile. Apart from your badge collection, you can also see a collection of trees that you've built previously in your profile page. These are the trees that I've built before. In community, you can see trees that have been built by other users. You can view or edit any of these trees by clicking on the edit tree button here. Let's try editing this tree built by Gene. Let's add another node and let's add ER expression. You can see here that the user placeholders are shown here. These two nodes have been added by me, so they're in a different color, and the placeholders here have been added by Gene, so they're in a different color. You can see the user's profile page by clicking on the placeholder. In the user's profile page, you can see the user's badge collection and a collection of trees built by the user before. You can go back to the game page by clicking on QR 2.0 in the top bar. This way, different users can collaborate together in building high-scoring trees. I hope you got a gist of how to go about building trees in the Cure. So, happy tree building!